Okay, so let's have the introduction to biochemistry. So, introduction will be composed on a review on the concepts, inorganic concepts and organic concepts that you need to understand biochem. So, we have atoms. So, let's start with atoms. So, if you have carbon 12, it means it has 6 protons, 6 neutrons, and 6 electrons. So, what differs carbon 12 from carbon 13 are the number of neutrons. So, 6 neutrons sa carbon 12, so that's protons plus neutrons. That's what it means. That's what that 12 means. And then you have 6 protons, 6, 7 neutrons, 6 protons, 8 neutrons. So, these are the 3 most abundant isotopes of carbon. So these are isotopes of carbon. Okay, so ang importance ani niya class is common use ani niya is in isotopic labeling. So usually manggod ang carbon nga naturally ni exist is carbon 12 because it's the most abundant. But then if you wanna know kung unsa nga carbon ang na-change sa reaction, like asa nga carbon ang from a single bond ang nahimong asa nga carbon ang nahimong double bond, so they label that carbon. So they kay ma-identify man ni ang carbon 13 using NMR. Okay, then electron orbitals. So this is the nucleus na adira ang proton o neutron, and then it's surrounded by the negatively charged electron. So these are what we call as the energy levels. Okay, so ang electrons class, they lie in a corresponding electron orbital. So we have 1s orbital, 3p orbitals, 5d orbitals, and 7f orbitals. So that's spdf 1357. Okay, so ang s orbital, ang shape ana niya is circle. It's a spherical. It's spherical in shape. That is why you only have 1s orbital kay spherical. What other shape could you make out of a sphere, diba? So it's just one. For p orbital, you have a 3 p orbitals because the shape of p orbital is dumbbell shaped. So yung ano yung shape niya, so we have 3 planes, right? We have x, y, z. So the p orbital, we have 3 p orbitals, that's px, so meaning it lies on the x-axis. We have py and we have pz. This is very important class. Knowing this the px, py, pz orbitals is very important. So let's stop with p orbitals because maura na siya ang significant, ang useful in biochem. Okay, so let's not go to d. And then so gikan sa nucleus, we have, as I've mentioned earlier, na energy levels. This is energy level 1, 2, 3, and 4, and so on and so forth. Okay, so the electron lies on different energy levels. So if you have 1s1 nga electron, for example, you have hydrogen. Hydrogen only has 1 electron, right? So that means ang iyang electron orbital will be, atomic electron configuration will be 1s1. So electron configuration meaning that this electron lies on this orbital. So what this means, class, is kaninga 1 means the first energy level, the electron lies on the first energy level, meaning it's the energy level nearest to the nucleus. And then the s orbital, the s means the orbital, the shape of the orbital, so it lies on an s orbital. Okay, and then this exponent nga 1 means nga na isa ka electron, 1 electron lies on this orbital. If you have 1s2, for example, the helium, if you have 1s2, meaning sa 1s orbital, you can have 2 electrons. The electrons, 2 electrons lie in this 1s orbital. That's what the electron configuration means. Okay? Now, redox reaction. So for redox class, you have to remember that these reactions go hand in hand, meaning they always go together. If you have reduction, you will always have oxidation in that reaction. Dili pwede nga in one reaction you will only have reduction and in another reaction you only have oxidation. No, that is not possible. Okay, so for redox class, it's very easy because we have a mnemonic. We have Geroa and Leora. So what this mnemonic means is that ang substance nga ni gain og electrons, the process is called reduction, and the substance nga ni gain og electrons is called an oxidizing agent. And then we have, if mo lose og electrons, ang process ana is called oxidation, and then the substance that lost electrons is called a reducing agent. Now, this one mostly is applicable to inorg. This is also applicable to organic, but there is an easier way to identify a redox reaction for organic. So for example, in this case, you have an organic reaction, diba? This is glucose plus oxygen to form carbon dioxide and water. So in organic class, the most reduced nga functional group is the alkane. So meaning ang substance, ang compound nga most reduced, an organic compound, is the methane. And then if magkadaghan, so the most reduced is the carbon that has is a substance that has the most CH bonds. Okay? So kung magkagamay na ganyan ng CH, for example, this one, you only have this one, right? So padung sa double bond, this will be, padung na sila magka-oxidize. This will be more oxidized here. And here, it's the most reduced. Meaning, magka-oxidize na ingon ana. So, meaning sa organic, this carboxylic acid is the most oxidized form. And then, if mo oxidize pag ang carboxylic acid, it will form carbon dioxide. This is already inorganic. Okay? So, which means, if in this reaction, carbon loses hydrogen. So, gikan dire, diba? The carbon here, gikan sa C6H12O6, nahimo siyang CO2. So, diba, gikan sa C, you have that, right? Double bond OH. So, you have that, right? C, 1, 2, 3, 4, 5, 6. One, two, three, four, five, six. Daghan sobra. This should be H. Sorry. So you have C, 2, 3, 4, 5, 6. So, I'm not sure if this is the structure of glucose, but I think this is the structure of glucose. I just think though. So, so gikan sa carbon, so here, ang carbon, diba, it's attached to hydrogen. Diba? So, this carbon is more reduced. And then, the carbon here became carbon dioxide. So, nahimo siyang C double bond O double bond O. Natangtang ang tanang CH bond, diba? Which means that this process is the oxidation half reaction process. That is why you have half reactions, okay? To separate the reduction of oxidation. But kung na oxidation, na dyan ay reduction. So remember, we have Leora and Geroa. So if carbon loses hydrogen, meaning it loses electrons, that means that this process is called oxidation. So lose electrons, oxidation. Meaning that this glucose here is the reducing agent. Okay, now, for oxygen, ang oxygen ni-gain siya og hydrogen. So, from O2, gikan sa O, nahimo siyang, it formed into H2O. So, it formed an OH bonds, 2 OH bonds actually. So, ni-gain siya og hydrogen, or ni-gain siya og electrons. Therefore, this process is called the reduction half reaction. And this is the oxidizing agent. So we have the reducing agent, the oxidizing agent. The reducing agent undergoes oxidation, so na-oxidize siya. Ang oxidizing agent undergoes reduction, nahimo siyang water. Okay? Now, electronegativities. For electronegativities class, you have learned this before, I think, from your inorg, if you had periodic trends. So this is one of the most important periodic trends. So class, I suggest I suggest that you internalize the periodic trends because those are very important concepts in chemistry. So for electronegativities, the electronegativity decreases as you go down the periodic table. So this is generally not for all because there are some anomalies in the periodic table. So as you go down, it's decreasing electronegativity. And then as you go to the right, it's increasing electronegativity. Which means that we expect fluorine to have the highest electronegativity, diba? So if you notice, these are the important atoms. The green ones are the important atoms, the important elements in organic. So you have carbon, nitrogen, oxygen, and hydrogen especially. So as you go to the right, you have increasing electronegativities. Okay? So for biochemistry, there are several types of bonds that are important. Okay? So we have covalent, we have ionic. So covalent is the sharing of electrons. Ionic is the swapping of electrons. And then we have polar covalent, which is somewhere in between. So because there is somewhere in between, you don't really need to think about this strictly, okay? So because the reality is that most bonds have both ionic and covalent characteristics, meaning most bonds have polar characteristics, okay? What you need to know in biochem, you have to know the relative strengths of these bonds. So you have to know that covalent bond is the strongest bond in biochem, and then you have ionic, and then you have hydrogen bond and hydrophobic, and then van der Waals. So this is the strongest bond, covalent bond, and then followed by ionic, hydrogen, so on and so forth. Okay, so that's what you need to understand and to know in biochem. So for ionic bonds, for example, you have sodium chloride, that's the table salt. You have the bond that's present in table salt is called ionic bond because they are swapping electrons. So from sodium, you have sodium ions. It ionizes one electron. So kung nilib ang usa ka negatively charged particle, so it makes the sodium become a positively charged ion. So that's a cation. And then ang chlorine, it accepts one electron. So since it accepts one electron, ni-accept siya og usa ka negatively charged particle, so that's why it became a negatively charged ion. And together, when they come into contact, then you form an ionic bond. So because this is positively charged and this is negatively charged, so there is an attraction between the two. So that's why you form this sodium chloride crystal. So ang sodium chloride crystal, this is the solid nga sodium chloride. Okay? Now, for covalent, ang covalent is the sharing of electrons. So, for example, it exists in hydrogen gas. So, di ba ang hydrogen atom only has one electron. And if it comes into contact with another hydrogen atom, then they share each other's one electron. So, they share, now they have two electrons. Each of them have two electrons. So, they share that and they form a single bond. So, they form this molecule. Remember nga, for every bond, nanay duha ka electrons. Okay, so this is composed of two electrons. So another example is for oxygen. So for oxygen gas, they're sharing 4 electrons. So 2 electrons from this oxygen and 2 electrons from the other oxygen. That's why you have O double bond O. Then it's the same case for nitrogen, that you have N triple bond N. Now, for electronegativity, as I've said, you have to remember the relative strengths of this electronegativity. Now, for biochem, you have to remember that O is the most electronegative among O and CH. Okay? Electronegativity increases as you go to the right, diba? That's oxygen, nitrogen, carbon, and hydrogen. Now, what is electronegativity man? So, electronegativity is the chemical property that describes the ability of an atom or a functional group to attract electrons or electron density towards itself in a covalent bond. So, ang electronegativity class, it's applicable if that atom is bonded to another atom. So, kung unsa ka mas ang electronegativity value describes kung unsa siya kakusog mubira og negative charge. Electron, whether that be electron or electron density. Okay, so kung unsa siya kakusog mubira og negative charge, mao na ang high nga electronegativity. Okay? So, So, ang significance aning electronegativity class is that because this is applicable when something is bonded to another, diba? So, whenever you find this, for example, this OH, you have an OH bond. Because O is more electronegative than hydrogen. This is a covalent bond, okay? Because O is, these two are sharing electrons. Because you do not have oxygen ion and hydrogen ion. Dili sila makaform og ionic bond. So, this bond is actually covalent. So ang significance aning electronegativity class is that if you have an OH bond, if you find an OH nga functional group, because oxygen is more electronegative than hydrogen, meaning that every time you see this OH, the electron density will be pulled towards oxygen. Meaning, because the electron density is pulled towards oxygen, oxygen will have a partial negative and hydrogen will become a partial positive charge. Kay naaman niya ang electron density. Iya mang gibira ang electron density because it is electronegative. Diba? So, so it's not like the sodium ion or chloride ion nga. Ionic siya, diba? It's a true positive and a true negative charge. This one is just a partial negative and partial positive. They do not form ions, but because of the electronegativity difference, they somehow become polar. Diba? So that is why, katong ganiha, nga we have covalent, we have ionic, and you don't really need to think about it strictly kay most bonds have polar characteristics. It's because of this one. Because of this electronegativity difference. Now, ang significance ani class is if you have OH, diba, that you have partially negative and partially positive. If you have another functional group, for example, if it comes into contact with something that has a carbonyl group. Now, that's oxygen and carbon, diba? Carbonyl. So oxygen is still more electronegative than carbon. So that means whenever you see a carbonyl group, the electron density is pulled towards oxygen. So that means ana na po din siya. So this becomes partially negative and partially positive. Meaning that if these two will react, most likely ang mechanism is that ang kining oxygen, this partially negative oxygen from OH, will attack the partially positive charge carbon of carbonyl. So ari siya sa carbon mo attack, not on the hydrogen, not on any part of the molecule, but on that partially positive part of the molecule. So that's only one mechanism. So the importance of this class is we are able to make a hypothesis on what the reaction, make a hypothesis on what how the reaction will proceed, and we can also construct mechanisms as to why the reaction happened that way. Diba? Because of this. Now, for bond strength, so while it takes more energy to break ionic bonds in a dry environment, so ionic bonds, it's like the bond in NaCl, diba? In living things, because we are 70% water, we are aqueous environments. Covalent bonds are stronger than ionic bonds. And H bonds are weaker than both. So remember sa katong table ganiha, in biochem, covalent bonds are stronger than ionic bonds. Bisan pag, if dry pa to, in dry environment, ionic bonds is stronger than covalent. Pero because we are living things, we are aqueous environments inside the body, diba? It's the reactions are made in the presence of in aqueous environment, diba? So covalent bonds are stronger than ionic bonds, and then H bonds are weaker than both. Now, however, even though these H bonds are weaker than both, remember that when you have large numbers of H bonding, this can be this can be significantly strong. So this is what I told you about polar covalent bonds. So you have covalent bonds, but it creates slightly this creates partial polar and partial negative and partial positive charges because of this electronegativity value. Diba? So that's actually the reason why oxygen is a well-known electron thief. So whenever you have oxygen bonded to another atom, most likely oxygen will be the more electronegative because oxygen is a well-known electron thief. So most likely naagid na sa oxygen ang electron density. Now, while there is no official charge on either atom, we can have a partial positive and a partial negative charge. Okay? So, now for hydrogen bonds. Ang hydrogen bonds class, they're still covalent bonds. But it's a special term for hydrogen nga nakabond with another electronegative atom. Because the electronegativity of hydrogen is so low, okay, because of the low electronegativity value. When hydrogen is bonded to something with a stronger value, with a high electronegativity, like for example, oxygen or H will be bonded to F, or H will be bonded to N. Diba? These are electronegative values. Diba? These one are electronegative elements. So when hydrogen is bonded to these forms polar. Diba? Partial negative dire niya, partial positive sa hydrogen nga side. Diba? This creates polarization kay partial negative o partial positive like any other polar covalent bonds. But the difference is that the electronegativity difference of this is so huge because hydrogen has very low electronegativity value. That is why we form the hydrogen bonds. So ang hydrogen bonds class, they will form kung ang hydrogen nga nakabond sa oxygen or hydrogen nga nakabond sa fluorine or sa nitrogen will interact with the oxygen nga nakabond pud og hydrogen. So kanang another nga inani ka polar. So kung nakabond pud na siya og hydrogen, or it will attack with something like this or this. So this is what we call as a hydrogen bond. So kung ang hydrogen naka-attach siya og highly electronegative, then that hydrogen can form a hydrogen bonding with another element, another electronegative nga element nga nakabond with hydrogen. Okay, so that's why in hydrogen bonds it occurs when you have among HO and F. So these are the elements that could form hydrogen bonding. So for example, in water, so a single water molecule can form up to 4 H bonds. So how? So this is the structure of water, diba? H2O. Okay, so because we have this OH, this is highly electronegative difference, diba? You have partially positive on H and partially negative on O. Because of this high electronegativity difference, you create this polarity. So this partially positive hydrogen could form a hydrogen bond with another water molecule, the oxygen of another water molecule. So this is already one H bond for this water molecule. Okay, and then this another hydrogen could form another hydrogen bond with another oxygen of another water molecule. And then because, as you know, ang H2O, it has 2 lone pairs in there. So meaning nanay duha ka electron density pagidira. So that means ang kining one lone pair will interact with the hydrogen of another water molecule because this hydrogen is attached to an electronegative O, diba? So this is also polar. So this could create hydrogen bonding and this could create another hydrogen bonding gikan sa another lone pair, diba? So this, imagine nga just one water molecule creates 4 hydrogen bonds, diba? So if this creates 4 hydrogen bonds, imagine if this will form a network of covalent bonds, meaning if kini nga water molecule mo form sad na siya og hydrogen bond, and then ang different na pod ang ni connect ng water molecule ni form og hydrogen bond, it forms a network of hydrogen bonds. So which makes the hydrogen bonding strong, okay? Especially in water, because one water molecule creates 4 hydrogen bonding, 4 hydrogen bonds. So those hydrogen bonds class makes the kanang characteristics of water or the properties of water very important. Okay, so for example, in water phase changes, kung gikan ka og liquid, when going from a liquid to a gas, remember nga ang molecules sa solid is very near, they are vibrating because dugol ra jud kaayo sila in that small space, diba? Compact kaayo and rigid. And then we have a gas, so which takes the shape of a container, and then lagyo siya gamay. For liquid. And then for gas, they are very far jud, lagyo kaayo, di ba? So when going from this kining medyo dugol nga molecules from liquid to a gas, because H bonding occurs in water, di ba? For example, these are water molecules. Because H bonding occurs here, the H bonds have to be broken down. That means it requires an increase in energy, because we need energy to break those H bonding, because the H bonding in water is significantly increased because of the network of H bonding. So that's why it requires an increase in energy kung gikan kag liquid padung sa gas. So that is why kung evaporate ang water class, di ba evaporation, it's from liquid to gas to vapor. So when water evaporates, mukuha na siya og energy gikan sa environment, which in turn ang environment will cool down kay nakuhaan man siya og energy. Okay? Which it's also the reason why ang sweating cools us. Okay? So, on the opposite pod nga process, kung gikan kag liquid padung sa solid, so gikan ani liquid padung sa solid, when water freezes, mo release pod siya og energy to the environment. Okay? Now, in solutions, ang ions mo dissociate in water. So, ang covalent molecules that form H bonds with each other can break the H bonds and separate into individual molecules. So, that's the same as sodium chloride dissolved in water, or you can have sucrose, table sugar, dissolved in water. So what happens is that, for example, in sodium chloride class, sa sodium chloride, when it's dissolved in water, mo-ionize na siya into sodium ion o chloride ion. So ma-separate ang sodium ug ang chlorine. Sodium ion o chloride ion. And what happens is that the water molecule surrounds each of them. So ang sodium, since positively charged man siya, ang negatively charged oxygen sa water mo protect niya. For chlorine, ang hydrogen po na mo protect niya. Kay positive, negative. Okay? So, it's the same thing as in if you dissolve kanang covalent nga molecule. So, like sucrose or glucose, kung i-dissolve nimo siya sa water, ang sucrose will be protected. Ang sugar will be protected by water molecules. So pareho ani, masurround po siya sa water molecules. Now, as I've said, katong due to the hydrogen bonding in water, it forms important properties of water. It causes this important properties of water. So for example, the cohesive property of water. So this the cohesion. So the cohesive property of water is due to the hydrogen bonding. So, ang katong hydrogen bonds, they allow the water molecules to be held together. Okay? So, mo nang, di ba, question is mutapok. So, it's actually due to the hydrogen bonding. And then we have high specific heat. So, high specific heat, we use water bath, di ba, para dili ma-change ang temperature sa kung unsa to atong gi-experiment. That's actually because of the high specific heat of water, meaning dugay pa mo evaporate ang water, dugay pa mo change ang phase sa water it needs pa more energy or more heat, diba? Because of the presence of hydrogen bonding. Hydrogen bonds, they absorb the heat when they break and release heat when they form. So they minimize the temperature changes. High heat of vaporization, as you know, many hydrogen bonds must be broken down for water para ma-evaporate, diba? So gikan sa liquid padung sa gas, you still need to break many hydrogen bonds. That's why it needs high heat or high energy. And then you have lower density of ice. So you've experienced this, ang lower density of ice, when you put ice in water, diba? Ang ice mo float yun siya. The reason for that, class, is the water molecules in an ice crystal are spaced relatively far because of hydrogen bonding. So, ang water, class, is a special case. So, di ba, usually, when we freeze or when we cool substances, they tend to compress. But in water, class, when it reaches 0 to 4 degrees, instead of mo compress siya, di ba, gipabugnaw na to, it's naturally, generally what happens to substances is that they become compressed. But for water, class, water expands when it reaches 0 to 4 degrees, meaning when it freezes. The reason for that is because of the hydrogen bonding in water. That is why it has a lower density. So that's mass over volume, di ba? Density is mass over volume. So nidako ang volume because ni-expand siya but constant ra ang number of molecules of water. So that means mugamay ang density. Okay? And then we have solubility. Well, you know nga ang water is called the universal solvent because ang polar molecules, water is highly polar, so it can dissolve polar molecules, and it is also attracted to ions because this is polar, meaning it has partial negative and partial positive. That's why it's attracted to both ionic and polar compounds, making those compounds soluble in water. We have other weak intermolecular forces. This is van der Waals and London forces. Then for pH, so